हेलो स्टूडेंट्स, इस वीडियो में हम बात कर रहे हैं रोल नंबर 3 के बारे में। हम बात कर रहे थे इक्वेशंस विच आर रिड्यूसिबल टू एग्जैक्ट फॉर्म। तो इस वीडियो में हम अनदर रोल नंबर 3 के बारे में बात करने सो दैट वी कैन मॉडिफाई सम नॉन एग्जैक्ट डिफरेंशियल इक्वेशन इनटू एग्जैक्ट डिफरेंशियल इक्वेशन। तो चलिए देखते हैं कि रूल नंबर 3 कैसे इक्वेशंस पे अप्लाई होता है और इसको कैसे अप्लाई करना है। So if we have a differential equation, non-exact differential equation, which is m of xy dx plus n of xy dy, then in rule number 3 what we have to see is that if the condition for this is that if m is actually in is of the form of y times some function of xy, okay, and n is of the form of x times some another function. These function can be different of xy. Now most important thing which you need to pay attention to is that these functions of xy, this means that xy as a whole is the variable. X and y are always in multiplication, or you can say that this is actually the variable u. You can say that this entire xy is actually the variable u. Xy should be in multiply, or every anywhere you see xy, they should be in multiply. Only then it will be called a function of xy. This is not x comma y, this is not this x comma y, it is x times y, right? So in the coming example also I will show you what we exactly mean by this, right? So this is the only thing which you need to pay attention to. Otherwise it is simple. You can see that m should be of this form, like some function of xy times y, and n should be of the form f2 some another function. These f1 and f2 can be different, of course, times some x. Then after that it's simple that we need our integrating factor. So if this condition is there, then we will have the integrating factor as 1 divided by mx minus ny. Simple as that, right? So this will be our integrating factor, and we know what we need to do with integrating factor. We need to multiply integrating factor to our equation so that our equations become reducible. So our equation get reduced to exact form. तो चलिए अब एक सिंपल सा एग्जांपल लेके ये पूरा प्रोसीजर समझने की ट्राई करते हैं. So here we have an example which we can on which we can use rule number 3. So let me, yes, so here these were the rules basically. These were the conditions which were required for rule number 3 to apply. Maybe we can enlarge this a bit. Yeah. So let's first of all let's see if the necessary condition is satisfied. These things. So let's see. So we can see that this is m, and in this we have a y multiplied, okay, and this is a function of xy, right? So this is like 1 plus 2xy. This thing is actually f1. This is a function of xy. We can kind of write it like 1 plus 2u, right, is equal to f1, where u is xy, x times y. So always remember, x and y should always be in multiplication. Whenever there is an x, there is a y multiplied with it, right? And here also we can say this is 1 minus xy, this is f2, and this is also a function of xy, and there is also x in multiplication. So the condition required to use rule number 3 is clearly here. So now after identifying the necessary condition, the rest of the procedure is quite easy. You just have to find the integrating factor. So as we saw that integrating factor is simply 1 divided by mx minus, here we saw that it is mx minus ny. So let's write it down. This whole thing is m, so this will become mx. We have to multiply this by x only. 1 plus 2xy, right? 1 upon minus n times y, so this will become xy, and 1 minus xy. So in denominator let's take this xy common to make our life easier. 1 plus 2xy, and this will become minus 1, and I guess we will get here plus xy, right? Yeah, so 1 plus 2xy minus 1 and plus xy. So these ones will cancel out and we will be left with 2xy plus xy will be 3xy, and there is a xy in multiplication outside, so this is 3x square y square. So we got our integrating factor, as simple as that. So this is the integrating factor. All we need to do is multiply it with the original equation. So let's copy the original equation. Let's copy this thing, and now we will paste it here. Yeah. So let's make some gap between these. So yeah, so let's just quickly multiply both sides with this. Let's multiply it this way, 3x square y square, and we will multiply this with also with 3x square y square. Now if you will check yourself, this equation is actually a exact differential equation, but we are not going to check because we trust the process. So yeah, so यहाँ पे ये y से y cancel हो जाएगा, x से x square cancel हो जाएगा. So finally we are left with, let's rewrite these equations. We will be left with 1 divided by 3x square y plus, and if we also divide this with this thing, we will get I think we will be left with 2 divided by 3, and one of the x's is gone and the y is also gone, so 2 divided by 3x, right, and whole thing is multiplied by dx, and plus here we will get 1 upon 3xy square minus, if we distribute these xy again here, so here we will get 1 by 3, this x will be gone and 1 y will be left on, dy is equal to 0, right. So now we know that this is an exact differential equation, so we will straight up put those integration signs here and start going over the process. Now let's quickly integrate this. So this will become 1 by 3y, and integration of 1 by x square will be 1 raised to x minus 2. The x has power of minus 2, so x की power minus 2 plus 1 will be minus 1, so this will become 1 by x, and we will get a minus 1 into x, so we can put this here, and in this case it is 2 by 3 x, so integral of 1 by x is ln of x, simple as that, plus, now in this term there is an x, so we will not integrate this, we will integrate this term only, so this will become minus 1 by 3, and the integral of 1 by y will be ln of y is equal to some constant. Yeah. So this is basically a final answer. Let's just clean it up a little bit. This will become, we can write this as 2 by 3 ln of x minus 1 by 3 xy, sorry, actually this should also be minus here, minus 1 by 3 ln of y is equal to c, right. So this is the final solution of our differential equation. This is the final solution. You can try to simplify it or convert it into any other form, but yeah, this is actually the final solution of our differential equation, and in the next video we will try to go over the derivation of this rule number 3. Yeah, so I hope you liked this video, and I will see you in the next video.